The final topic that we'll discuss from Chapter 16 of the Seaborg text is called selective control, and we'll introduce two different methods of selective control that are appropriate for different situations. These selective control methods are used in general when the number of controlled variables is not equal to the number of manipulated variables. The first method of selective control that we'll discuss is called auctioneering. Auctioneering is used when there are more controlled variables than there are manipulated variables. Consider the case where we have a tubular catalytic reactor with a cooling jacket. And the temperature of the reactor contents along the length of the reactor is measured at multiple points, 1, 2, 3, 4, and 5 here. Now, all 5 of these temperatures cannot be controlled because we have only one manipulated variable, which is the flow rate of the cooling water to the jacket. But what is important is that a hot spot does not develop. So we want to control only the hottest of these temperatures. We do this by auctioneering, where the hottest temperature is selected by an element between the temperature sensor transmitters and the controller. And the error signal is computed using the hottest measured temperature, because we don't know where the hotspot might develop along the length of the reactor. Split range control is for the opposite situation, where we have more manipulated variables than we have controlled variables. Split range control is also commonly used in control loops for temperatures. Let's go back to our control loop for the temperature on our jacketed reactor. Here we're not showing the reactor, but we're showing the cascade loop where the reactor temperature is measured and is used to select a set point for the jacket temperature. Now let's suppose that the jacket temperature can be modulated by either adding cooling water to the jacket or by adding tempered water to the jacket. The tempered water would heat the jacket while the cooling water would cool the jacket. Split range control is used by the controller to select which manipulated variable to change based on the controller output. In this case, when the controller output is in the lower end of its range, the cooling water valve is manipulated, and when the controller output is near the higher end of its range, the tempered water valve is manipulated. We might need to supply tempered water to heat the reactor when the reactor is initially starting up and the exothermic reaction has not ignited yet. And then once the exothermic reaction is underway and heat is being generated, the controller output drops, closing the tempered water valve and opening the cooling water valve. In some cases, split range control is used where the ranges of output that manipulate the two valves overlap. Split range control is common in temperature control loops. Split range control might also be used for something like a pH control loop, where either an acid or a base must be added depending on whether the pH being controlled is too high or too low. To summarize the topics that we discussed from Chapter 16 of the Seaborg text, we introduced 3 advanced control strategies for feedback control loops. The first was cascade control, which can be used to speed up the responses of very slow processes. Cascade control uses 2 nested feedback loops where the slow process provides the set point for a fast process. Cascade control has 2 sensors and 2 controlled variables, but only 1 manipulated variable. Only one of the 2 controlled variables has a set point that's selected by the operator, and the other controlled variable has a set point that's selected by one of the controllers. The next strategy that we talked about was the Smith predictor, which can be used to reduce the effects of large time delays. The ideal Smith predictor can be derived from the direct synthesis tuning method that we introduced in Chapter 12. Selective control strategies are used to choose which controlled variables to pair with which manipulated variables. We looked at examples of both auctioneering and split range control. Auctioneering is used when the number of controlled variables is greater than the number of manipulated variables. And a selector is used to choose which controlled variable is paired with the MV. Split range control is used when there are more manipulated variables than there are controlled variables. In split range control, the controller output goes to multiple controlled variables, which each operate over different ranges of the output signal.